Okay. So, good afternoon to one and all. In the previous lecture of electrical machine first, we have discussed regarding characteristics of DC motor. Uh, so today we will discuss regarding losses and efficiency. But before discussing about the losses and efficiency, we will discuss the previous one point is that we have, I think, two characteristics left, that of DC compound generator characteristics. In that we have already derived one characteristic, that is torque versus armature current characteristics of DC compound motor. Compound motor ची characteristics आपण already बघितलेले आहेत. So see, we will just overlook on that. See, in case of compound motor, there is a both field winding. That means in that compound is nothing but in that there are shunt field winding, it can be also used, series field winding it can be also. त्याच्यामध्ये shunt field winding पण यूज केलेले आहे, series field winding पण यूज केलेले. If the series field winding, it is so adjusted that the flux, that is resultant value of flux, if it is get additive or it may be more, then these types of generator we can call it as a cumulatively compounded generator. And if the series field winding turns, it should be so adjusted that if the resultant value of flux it is less or it may be reduces to that of main flux, so at that situation we can call it as a differentially compounded motor. त्याला आपण differentially compounded motor म्हणतो. Okay, so see, in case of cumulatively compounded motor, so total value of flux it will be increases, and in case of differentially compounded generator, differentially compounded motor, the total value of flux it will be reduces. So generally we are using a cumulatively compounded motor because the flux increases, that means the torque of that machine it will be greater. त्या मशीनचा जो काही टॉर्क आहे तो ग्रेटर आहे. So we have derived the characteristics, that is torque versus armature current characteristics for that type of motor. त्या टाइपच्या मोटरची आपण कॅरेक्टरिस्टिक डिराइव्ह केली होती, that is torque versus armature current. In that torque versus armature current characteristics, torque is plotted on y axis, armature current it can be plotted on x axis. See, do you know that the two equation, that is torque TA is directly proportional to phi into Ia? Okay, directly proportional to phi into Ia. So do you know that in case of DC compound motor, phi is directly proportional to supply current, or it may be it is depends upon IL. IL वरती depend राहील. So so that the total value of flux it will be reduces, that it will be increases, that is resultant value of phi r, it is equals to flux produced by shunt field winding plus flux produced by series field winding. ही जर value increase झाली, automatically this flux it will be increases, so torque it will be increases in that same proportion as the armature current increases. ज्यावेळेस IA increase होईल त्यावेळेस torque काय होईल, increase होईल, and this is greater than that of shunt motor. Shunt field winding पेक्षा greater असेल because in that the series field winding flux is also added. त्याच्यामध्ये series field winding चे flux काय होत आहेत, add होत आहेत. Now see, in case of differentially compounded motor, that is phi r is equals to phi sh minus phi sc. If the flux or the series field winding turns so adjusted that the resultant value of flux it will be reduces. Resultant value of flux it will be reduces. कशामधून reduce होतोय, phi sh पेक्षा ते कमी आहेत. phi sh मधून हे मायनस झालं की total flux काय will reduce. So that the torque versus armature current characteristics of that of cumulatively compounded motor, it is less than that of shunt motor characteristics. And in case of shunt motor चा काय आहे characteristics, torque TA is directly proportional to phi into Ia. In case of shunt motor, phi is constant, so the torque is directly proportional to only Ia. As the Ia increases, torque increases, so it gives a linear proportion. So this line it will be shows that the linear proportion, or it may be torque versus armature current characteristics of shunt motor. Okay, so this we have already discussed previous one, but also today we have just overlook on that. Now next one characteristics, that is torque versus armature current. Next one is nothing but speed versus armature current characteristics. Speed versus armature current characteristics. See, in case of speed versus armature current characteristics, do you know that the equation of speed N is directly proportional to EB divided by phi. So in case of compound motor, both the series field winding and shunt field winding is connected. Series field plus shunt field winding is connected. So in case of shunt field, the flux of the motor, it is constant. So normally the shunt field motor characteristics is that आपण shunt field motor ची characteristics बघितलेली आहे. So this yellow line or yellow graph, it will be shows that the characteristics of shunt motor. Shunt motor ची characteristics काय होती? At a no load condition, the motor it will be running at a constant speed. Motor जी आहे ती constant speed ला run होते. When the armature current increases, that means if the armature current increases, so slightly the speed of the motor it will be decreases. आपण ही speed control technique पण बघितलेली आहे. Or we can conducted in the practical, that is load test. Load test म्हणजे load put करतोय, म्हणजे torque increase करतोय. If the torque increases, armature current it will be increases. Okay, or supply current it will be increases. That means supply current increases, phi is constant, armature current increases. If the armature current increases, automatically the speed of the motor it will be start decreasing, or it is less than that of no load speed. So we can generally use the DC shunt motor for constant speed application. Constant speed application ला आपण generally DC shunt motor use करतो. Now these characteristics, that means this line shows that the characteristics of shunt motor. Again, same proportion or the same information related to that is that the resultant value of flux in case of compound motor, if it is additive, that means phi SH plus phi R. Phi SH plus phi R. If the resultant value of flux, it is additive value, बघा flux काय होता है? Increase होता है. According to this equation, what happen if the flux increases? Flux increase झालं, what happen? Regarding speed?
Decreases.
Speed decreases. So see, in which types of compound motor the flux it will be increases? कोणत्या टाइपच्या मोटर मध्ये फ्लक्स इनक्रीज होत आहेत? कंपाऊंड मोटर मध्ये म्हणतोय मी. In which type of compound motor the flux it will be increases, or we can call it as a additive flux. कोणत्या टाइपच्या मोटर मध्ये असतात? Cumulatively compounded motor, right? No. So see, in case of cumulatively compounded motor, the resultant value of flux phi R is equals to shunt field winding flux plus that means plus series field winding flux. So total flux or the resultant value of flux it will be increases. If the resultant value of flux it will be increases, so speed of the motor it will be decreases and it is below to that of shunt motor's characteristics. बघा ही जी काही लाईन ड्रॉ केलेली आहे, so this line or this graph it is nothing but cumulatively compounded motor speed armature current characteristics. बघा काय? If the current increases, so load on the motor it will be increases, or if the load increases, the current taken by the motor it will be increases. For increase the value of the current, the speed of the DC cumulatively compounded motor it will be decreases and the curve lies below to that of shunt motor characteristics. Shunt motor characteristics पेक्षा काय आहे तो? Below आहे. Okay. Now in case of differentially compounded motor, so resultant value of flux phi R is equals to phi R जो आहे तो phi SH minus phi SE. That means total value of flux it will be reduces by that of phi SE value, flux produced by series field winding. So this curve, if the resultant value of flux is reduces, what happen in the speed? According to this equation,
Increases.
Speed is increases. Okay, see speed काय होता है? Increase होते, and these characteristics it is lie above the shunt motor characteristics. See this one graph, whether you are visible or not. हा जो काही graph आहे, so see this is the characteristics of the compound motor, that is differentially compounded motor. I have given name here also. याचा जो काय कर्व असेल त्याचं स्पीड शंट मोटरच्या स्पीड पेक्षा काय आहे, ग्रेटर आहे किंवा ते इन्क्रीज होते because of the flux value it should be decreases, right? No, so this is the speed versus armature current characteristic. See, as the armature current increases or as the load increases, the armature current increases. We are taking reference here shunt motor or the shunt characteristics. Shunt field winding as it is ठेवतोय आपण, so flux of the shunt field winding remains constant. We are adjusting series field winding such that if the flux produced by that machine or that compound motor, if it is additive flux or it may be more than that of shunt motor flux, at that situation the speed of the motor it will be decreases. So the curve of cumulatively compounded motor it will be lies below to that of shunt motor curve. In case of differentially compounded motor, the resultant value of flux it will be reduces, and we know that if the resultant value of flux it will be reduces, the speed of the motor it will be increases according to this equation. So the flux quantity it is less than that of shunt motor flux. Shunt motor flux cha less ahe quantity, so the speed of the motor it will be more or it may be increases, so it is more than that of shunt motor characteristics. So the curve it will be like this. This is the differentially compounded motor curve. Okay, see, in cumulatively compounded motor, series field winding is connected in such a way that the magnetic field produced by it helps the flux production by shunt field winding. It will help is nothing but additive flux, and series field is directly proportional to load current. So the total flux increases. Series field जे आहे ते phi is directly proportional to load current आहे. Okay, as the supply current increases किंवा load current it will be increases. Load current कधी increase होईल, ज्यावेळेस load increase केला जाईल. That means if load increases, supply current taken from the machine it will be increases. If the supply current taken from the machine it will be increases, so the armature current of the motor it will be increases. If the armature current of the motor it will be increases, the flux production in the series field winding it will be increases. Due to that increased flux production, the resultant value of flux it will be increases. If the resultant value of flux it will be increases, the speed of the motor it will be decreases, and it is less than that of shunt motor characteristics. This curve it will be below to that of shunt motor characteristics. Okay, and next one, if the series field winding it will be such adjusted that it will be opposed to that of shunt field winding. Opposed to that of shunt field winding is nothing but resultant value of flux it will be less than that of shunt field winding flux, that is phi SC is minus phi SC. So if the resultant value of flux it will be reduces, then the according to equation the speed of the motor it will be increases, and if the speed of the motor it will be increases, as the current it will be increases. Current increase झाल्यामुळे काय होतंय, फ्लक्स प्रोडक्शन इंक्रीज होते. ते फ्लक्स प्रोडक्शन काय करते, अकॉर्डिंग टू दिस इक्वेशन phi r is equals to phi sh minus phi sc. If the series field winding current it will be increases, series field winding मधून फ्लो होणारा करंट इंक्रीज झाला की phi sc फ्लक्स इंक्रीज होती. phi sc फ्लक्स इंक्रीज झाला की phi r, that means resultant value of flux it will be reduces. If the resultant value of flux it will be reduces, the speed of the motor it will be increases according to this equation. And if the speed of the motor it will be increases, as the torque as the armature current of the motor it will be increases. That means this curve it will be lies above to that of shunt motor characteristics. Shunt motor च्या characteristics च्या काय आहे तो above आहे. Okay, getting all of you? Speed, armature current characteristics. Is there any doubt याच्यामध्ये? याच्यामध्ये कोणाला काय डाउट असेल तर जस्ट आस्क, अदरवाइज वी विल मूव नेक्स्ट. Getting no?
Yes, sir.
Okay. So see, just understand by using equation, you can easily explain this one, or just I think you people know how to read the characteristics. Characteristics जर तुम्ही लक्षात ठेवली तर त्याच्यावरून तुम्हाला एक्सप्लेनेशन देता येईल. Can anyone know how to read the characteristics? How to read these characteristics? कशी रीड करतो आपण जनरली? कोण एक्सप्लेन करेल का हे characteristics? Characteristics is nothing but one type of graph, or it is called as graphical representation. त्याच्यावरून आपल्याला काहीतरी इन्फॉर्मेशन मिळते. Can anyone explain these characteristics? Anyone? Can anyone able to explain? So it is simple. See, we are explaining like that. The voltage of the machine, or it may be voltage, it can be plotted on y-axis. Current, it can be plotted on x-axis. How these characteristics it can be represented? This characteristics is starting from O position, or it may be origin position, and as the value of current, suppose I have represented point here. Suppose one point here. Here it is 1 ampere. Here it is somewhat 1 volt. Suppose here it is 2 ampere. Here it is somewhat 2 volt. See, that means this characteristics, it is plotted against the voltage versus current, or this characteristics shows that the voltage current characteristics. On that voltage it is plotted on y-axis, current it is plotted on x-axis. As the current of the machine, or it may be current, it will be increases. The speed of the the voltage of that machine, it will be also increases in the same proportion. Same proportion मध्ये increase होते, so that we can derive equation V is directly proportional to I. Okay, that means as the current increases, the voltage it will be also increases, and it will gives a linear curve, or it may be one linear characteristics passing from origin. So this is the explanation regarding that characteristics. किंवा आपण त्याच्यावरून अंडरस्टँड करू शकतो की या दोन पॅरामीटर वरून याचं बिहेवियर काय. Similarly, all other characteristics should be also explained. Okay, so this is nothing but how to read the characteristics. Now we will see the next one type of characteristics, that is last one. Before discussing last one, we will discuss last one characteristic, then we will discuss application. See, the speed torque characteristics, speed and torque characteristics. Again, do you know that suppose we have taken here the shunt motor as a reference motor. So in case of shunt motor, how was the characteristics? Shunt motor ची characteristics कशी होती? Speed torque. Can anyone tell me? I will draw the characteristics of shunt motor here. Speed and torque. Here it is, N is plotted on y-axis. Torque it can be plotted on x-axis. Can anyone? At the no load condition, the speed of the DC shunt motor, it will be constant, or it may be rated. DC shunt motor, it is run on the constant speed at a no load condition. Can anyone tell me how it these characteristics? आपण ऑलरेडी झालेलं आहे. शंट मोटरची characteristics आपण ऑलरेडी डिराइव केलेले. Can anyone?
जसं जसं सर टॉर्क इन्क्रीज होईल का नाही तसं स्पीड कमी होणार.
Okay, that means if the torque increases, the speed of the motor it will be decreases. That means these characteristics it will be like this. Okay, so see. Okay, ही शंट मोटरची characteristics होती, right? No, बरोबर ना?
Yes sir.
Okay, see, that means if torque increases, torque कधी increase होतो ज्यावेळेस load increase होईल. If the torque increases, load increases, the torque of the motor it will be increases. If the torque of the motor it will be increases, the speed of the motor it will be slightly decreases, or it is less than that of no load speed. No load speed पेक्षा काय असतं? Less असतं. See, in case of compound motor, again similar explanation. That is, In case of compound motor, again there are two types of compound motor. One is cumulatively compounded motor, another one is differentially compounded motor. एक cumulatively compounded motor है, एक differentially compounded motor. See, suppose we have consider here one of the constant speed. एक अपन constant speed consider करो. That means this machine it can be run as a constant speed. When there is a series field turns, it is 0, or it may be when the series field turns, or it may be it is run as a no load condition. No load condition ला run होते त्यावेळेस त्याचं स्पीड काय आहे 0 आहे. See, if the torque of the machine it will be increases, that means if the load increases, load ज्यावेळेस increase करतोय, at that situation torque it will be increases. Okay, if the torque it will be increases, when the load of the machine it will be increases, and if the torque of the motor it will be increases, the speed of the cumulatively compounded motor it will be decreases. Cumulatively compounded motor च speed काय होते decrease होते. See the explanation for that, it is nothing but again in case of compound motor, the resultant value of flux phi r is equals to phi sh minus phi sc. So this is for differentially compounded, and phi r is equals to phi sh plus phi sc. Okay, see, as the load increases, what will happen? Load increase झाल्यानंतर काय होईल? Current increases. Okay, see, आपण लोड टेस्ट कंडक्ट केली होती डीसी शंट मोटरची बघा. इफ द लोड increases, that is आपण कन्सिडर केलं होतं S1 minus S2 into drum radius R into 9.8 according to we are calculated torque. म्हणजे जसं जसं आपण S1 S2 वाढवत होतो किंवा आपण लोड त्या मशीनवरती केजी मध्ये पुट करत होतो. So when we are putting a load on that machine, then the torque of the motor it will be increases. Okay, what will happen again in case of torque equation? TA is directly proportional to phi into Ia. Okay, phi into Ia. See, if the load increases, what will happen? Torque increases. If the torque increases, what will happen? The armature current it will be increases. Okay, armature current काय will increase will na?
Yes, sir.
Okay, I will draw here cumulatively compounded motor also. See, this is the shunt field winding. This one is the armature of the motor. This one is the armature of the motor, and here it is one series field, and here it is supply. Supply voltage it can be provided. Supply current IL we can represent. This one is the IA. Here it is ISH. Here it is ISC. ISC and IL are same. ISC is equals to IL. And here suppose here it is motor. There is one of the drum. It can be connected and load it can be putted. This is the rotation of the motor having and some revolution per minute. Somewhat load it can be putted on that of machine. See, if the load on the motor it will be increases, motor वरचा load increase झाला, automatically torque it will be increases. That means the turning or twisting force it will be increases. If the torque increases, current taken from the supply it will be increases. Right? No? बरोबर ना?
Yes, sir.
Suppose consider this ISH is constant. Suppose I will take example here. 10 ampere current initially it will be flow, and 1 ampere current as a shunt field current. So the armature current IA किती येईल या कंडिशनला? ज्यावेळेस मी IL 10 ampere कन्सिडर करतोय, ISH 1 ampere आहे. What is the value of IA?
9.
10 minus 1 is nothing but 9 ampere. Okay, see, as the load increases, the torque it will be increases. If the torque it will be increases, then the current taken from the supply it will be increases. Suppose at that situation the current taken from the supply it will be increases. Suppose the current taken from the supply it is nothing but 12 ampere. ज्यावेळेस मोटरवरचा लोड इन्क्रीज झाला त्यावेळेस टॉर्क इन्क्रीज झाला. Do you know that the proportion torque TA is directly proportional to IA or phi IA? So the armature current it will be increases. When the torque it will be increases, current taken from the supply it will be increases. Current taken from the supply it will be increases. That means armature current flowing through the armature it will be increases because shunt field winding having a constant current, or we are not changing in the shunt field winding. See what will happen if the current flowing from this it will be increases. या series field winding मधून फ्लो होणारा करंट इन्क्रीज झाला काय होईल?
Armature current increase will.
ओके आर्मेचर करंट इन्क्रीज होईल ते मान्य आहे. बट सिरीज फील्ड वाइंडिंग मधून करंट इन्क्रीज झाला. एखाद्या फील्ड वाइंडिंग मधून जर करंट फ्लो होत असेल आणि त्याच्यामधला करंट इन्क्रीज झाला काय हॅपन होतं? व्हॉट अबाउट फ्लक्स प्रोडक्शन? If the current increases, what about flux?
Increase.
Flux is also increases, no? That means
Yes.
या फील्ड वाइंडिंग मधून या फील्ड वाइंडिंग चे क्रिएट होणारे जर फ्लक्स आहेत ते फाय एससी इट विल बी इन्क्रीजेस. बघा इफ इट इज अ क्युम्युलेटिव्हली कंपाऊंडेड मोटर फ्रॉम दिस इक्वेशन when we can call it as a cumulatively compounded motor if the flux it is additive किंवा 5sh पेक्षा जास्त फ्लक्स असतील additive असतील then we can call it as a cumulatively see the flux 5sc produced due to that increased current it will be increases. If the 5sc flux it will be increases, the resultant value of flux phi r, what will happen in case of phi r?
Increases.
Phi r it will be increases. See total किंवा resultant value of flux काय will increase will. If the resultant value of flux it will be increases according to equation n is directly proportional to eb divided by phi. Flux increase झाले what will happen in the speed?
Decreases.
Speed is decreases. कोणत्या मोटरसाठी? कोणत्या मोटरचं बघितलं आपण? प्लस 5sc कोणत्या मोटर मध्ये असतं? Cumulatively compounded motor. See the graph. This curve it will be like this. The speed of the motor it will be decreases and it will be lies less than that of shunt motor characteristics. So this is the cumulatively compounded motor characteristics. ही जी काय आहे ती cumulatively compounded motor characteristics आहे. Okay. So this one is the cumulatively compounded motor characteristics. Now reverse explanation of that. याच्या reverse आता explanation. So see in case of differentially compounded motor, differentially compounded motor साठी काय इक्वेशन? phi r is equals to phi sh minus phi sc, right? No, phi r is equals to phi sh minus phi sc. That is flux produced by shunt field winding. त्याला ते सिरीज फील्ड वाइंडिंग चे फ्लक्स काय करतील? अपोज करतील. That means minus phi sc. See again the same example. If the load increases, load of differentially compounded motor it will be increases. Differentially compounded motor चा load increase केला काय इफेक्ट होईल? फर्स्ट वन
Torque increases.
टॉर्क इट विल बी इन्क्रीजेस. आपण टॉर्कच इन्क्रीज करतोय ना. जसं टॉर्क इन्क्रीज करेल म्हणजेच लोड इन्क्रीज करतो. So if the load increases that means torque of the machine it will be increases. If the torque of the machine it will be increases, to meet that value of torque the current taken from the supply it will be increases, right? No,
Yes.
सप्लाय कडून घेतलेला करंट काय होणार? इन्क्रीज होणार because it is a self regulating machine. If the current taken from the supply it will be increases, the flux produced in the series field winding it is also increases. Okay, right? No, सिरीज फील्ड वाइंडिंग मध्ये प्रोड्यूस होणारे फ्लक्स इन्क्रीज होतील का डिक्रीज होतील? इफ द करंट इन्क्रीजेस,
Increase होतील.
लक्ष देते का? हॅलो, मी काय सांगतोय लक्ष देते का तुमच्या? अदरवाइज आय विल ड्रॉ अनदर वन.
No, sir.
येत नाही लक्षात का? Okay, see, I am discussing regarding compound motor, that is differentially compounded motor. See, differentially compounded motor, the resultant value of flux phi r, it is less than the flux produced by shunt field winding, that is phi sh minus phi sc. That is series field winding turns, it will be so adjusted that series field winding turns, it will be so adjusted that it will oppose to the flux production of shunt field winding, or it may be the resultant value of flux, it will be less as compared to that of shunt machine. Shunt machine ला compare करता त्याचे flux काय असतील, कमी असतील. See, this is one equation. Now I am discussing when the load increases, when the load on the motor, it will be increases. That is, we are discussing particularly on compound motor, that is differentially compounded motor. आपण differentially compounded motor साठी मी explain करतोय differential compound motor. Okay, see, as the load increases, what will happen? Torque of the machine, it will be increases.
Yes, sir.
Okay, see, that means we are drawing characteristic speed versus torque. Load increase झाला म्हणजे torque काय करतोय आपण, increase करतोय. Now we want to derive what effect on the speed. Speed वरती काय effect होते हे आपल्याला derive करायचं. See, if the load increases, the torque of the motor, it will be increases. See, if the torque of the motor, it will be increases, then to meet that value of torque, the current taken from the supply, it will be increases, right? No, otherwise I will draw diagram. This is the shunt field winding, here it is armature of the motor, here it is series field winding of the motor, and here it is supply, it can be provided, that is V volt. Current taken from the supply, this one is the armature current, this one is the shunt field winding current, ISH. See, as the load on the motor, it will be increases. Motorचा load increase झाला, torque TA, it will be increases. That means torque TA, it will be start increasing. If the torque TA, it will be start increasing, we want to understand what effect it will be happen on the speed of differentially compounded motor. See, if the torque increases, to meet that value of torque, current taken from the supply, whether it is increases or decreases, increases, right? That means IL, that is value of supply current, or IL, it will be increases. So see, value of supply current IL, it will be increases, or here it is in series, so series field winding current, it will be also increases. If the series field winding, it will be increases, what about flux?
Increases.
Series field winding madle flux म्हणतोय मी, that is phi sc, it will be increases. See, that means here this value of this phi sc, it will be increases. If the value of phi sc, it will be increases, what happened regarding phi r?
Decrease.
That is resultant value of flux, म्हणजे resultant किंवा final जे काय flux असतील त्याची value decrease होईल, right? No, that is phi r, it is decreases. Resultant value of flux, it will be decreases. And do you know that the equation N is directly proportional to EB divided by phi, that is EB divided by resultant value of flux. If the flux decreases, what about the speed?
Increase.
Speed of the motor, it will be increases. Which motor? कोणत्या मोटरचा?
Differential.
Differentially compounded motor. See, as the torque increases, the speed of the DC differentially compounded motor, it will be increases, and the curve, it will be lie about to that of shunt motor characteristics. जी काही शंट मोटरची characteristics असेल त्याच्या above curve काय होणार, lie होणार. Okay, so this is the explanation related to speed torque characteristics of both cumulatively compounded and the differentially compounded motor. Okay, getting all of you? लक्षात आलंय का? त्याच्यामध्ये कोणाला काय डाऊट आहे? हा, आहे का कोणाला काय डाऊट? If you have any doubt, then ask directly, because this is one important part. And once,
No, sir.
okay, So see, once you seen all these characteristics, then somewhat you may get confused. म्हणजे कशी डिराइव्ह केलेली आहे, कोणता फॉर्म्युला, याच्यासाठी काय प्रूफ आहे, किंवा ती तशीच काय येते कॅरेक्टरिस्टिक्स. सो यू मे गेट कन्फ्युजन, so that all of you understand better. Okay, so these are the all three characteristics of compound motor. In the previous lecture we have also discussed the characteristics, all three characteristics of series motor and shunt motor. Series मोटरच्या आणि शंट मोटरच्या कॅरेक्टरिस्टिक्स पण आपण काय केले, डिस्कस केले. ओके, दॅट इज टॉर्क वर्सेस आर्मेचर करंट कॅरेक्टरिस्टिक्स, speed versus armature current characteristics, and the speed torque characteristics. Speed torque characteristics. Okay, now we will see the application of DC cumulatively compounded motor and the differentially compounded motor. See the motor that is cumulatively compounded motor, it is having an high starting torque. Okay, cumulatively compounded motor ji ahe, it is having an high starting torque. That means at minimum value of load, the speed of the motor, it will be get somewhat no load speed or the maximum speed, having an high starting torque. So they can operate even at no load condition. So see, in case of series motor आपण नो लोड कंडिशन ला ऑपरेट करतो का? ऑपरेट करतो का? No. So see, series motor we cannot operate on no load condition, but we compounding both the winding. ज्यावेळेस आपण both winding compound करतोय, आपल्याला टॉर्क पण मॅक्सिमम मिळतोय, and we are able to operate that motor on no load condition also. ही जी काय मोटर आहे, आपण नो लोड कंडिशनला पण काय करू शकतो, ऑपरेट करू शकतो. सी, दे कॅन बी ऑपरेटेड इवन ॲट नो लोड as they run at moderately high speed at no load. Okay, at no load condition it will be run as a moderately high speed. Hence cumulatively compounded motor are used for following application. Cumulatively compounded motor, it can be used for a following application. First one application is that elevators. First one application, it is nothing but elevator. Second one is nothing but rolling mills. Elevators, rolling mills, punches, shears, and planners. So these are some of the MCQ option. That means you want to choose particular option for a particular application or particular type of motor. Suppose question विचारला असेल, which types of motor is suitable for particular application. एखादा application लिहिला असेल, which types of motor is suitable for rolling application, which types of motor it is suitable for shears and punches. Okay, so see, like that. Okay, so these are the some of the application of cumulatively compounded motor, because it is having an high starting torque also. Now we want to discuss the application of compound motor. See, the speed of this motor, it will be increases. बघा, आपण कॅरेक्टरिस्टिक्स बघितली, स्पीड टॉर्क कॅरेक्टरिस्टिक्स, स्पीड आणि टॉर्क कॅरेक्टरिस्टिक्स आपण आताच ड्रॉ केली होती. दॅट इज स्पीड वर्सेस टॉर्क कॅरेक्टरिस्टिक्स, TA, and here it is speed. As the torque of the motor, it will be increases. Torque increases म्हणजे लोड काय होतो, इन्क्रीज होतो. म्हणजे लोड इन्क्रीज केला तरच टॉर्क इन्क्रीज होईल. सो इफ द टॉर्क ऑफ द मोटर, इट विल बी इन्क्रीजेस, द स्पीड ऑफ द मोटर, इट विल बी ऑल्सो इन्क्रीजेस इन केस ऑफ डिफरन्शियली कंपाउंडेड मोटर. बघा, आपण आताच कॅरेक्टरिस्टिक्स बघितली. दिस वन कॅरेक्टरिस्टिक्स, that is the differentially compounded motor. Here it is, see, when the torque increases, the speed of the motor, it will be increases. मोटरचं स्पीड काय होते, इन्क्रीज होते. ओके, जसं जसं लोड इन्क्रीज करल, so we can increase the torque, and if the torque increases, the speed of the motor, it will be increases. As the speed of the motor, it will be increases, having an more torque or more load. जास्त लोडला जर मशीनचा टॉर्क किंवा स्पीड इन्क्रीज होत असेल, व्हॉट विल हॅपन, कॅन एनीवन टेल? हा, सपोज एखादी मशीन आहे किंवा एखादी मोटर आहे, जेवढा तुम्ही लोड इन्क्रीज कराल त्याचं स्पीड इन्क्रीज होते. ड्यू टू दॅट इन्क्रीज स्पीड, व्हॉट इज द इफेक्ट ऑन दॅट मशीन? Can I give example? See, suppose machine it can be running on 1500 revolution per minute at somewhat minimum load. एका minimum load ला machine काय 1500 revolution per minute न run होते. If the load increases, that means suppose I have putted the load 80%. Suppose I have putted the load 80%. Then the speed of the motor it will be increases, that is somewhat 2000 revolution per minute. म्हणजे स्पीड काय झालं, इन्क्रीज झालं. काय इफेक्ट होईल मोटर वरती? Can anyone? मशीन वरती काय इफेक्ट होईल?
5 decreases.
नाही, in general what will happen regarding that machine? Okay, see, there is a unstable operation of the machine, it will be start. Okay, that means somewhat the machine it will be get viable or it may be unstable, कारण लोड पण इन्क्रीज होतोय आणि जेवढा ज्या पटीने तुम्ही लोड इन्क्रीज करताय त्या पटीने मोटरचं स्पीड काय होतंय, इन्क्रीज होते. ओके सर, विदिन 5 minutes. ओके, सी, इफ द स्पीड इन्क्रीजेस, मशीनचं स्पीड इन्क्रीज झालं की त्याचा लोड इन्क्रीज होतो किंवा त्याचं अनस्टेबल ऑपरेशन स्टार्ट होईल आणि त्याच पटीने आपण लोड पण काय करतोय, इन्क्रीज करतोय. सो द मोटर इट विल बी गेट अनस्टेबल. ओके, सो दॅट मीन्स अनस्टेबल ऑपरेशन ऑफ द मशीन इट विल बी स्टार्ट. बघा, फॉर एक्झाम्पल, इफ इन युअर होम देर इज अ chap cutter is there, and if in case of chap cutter, if the load of that chap cutter or it may be cutter it will be increases. लोड इन्क्रीज केला म्हणजे लोड इन्क्रीज केल्यानंतर रोटर ब्लॉक होण्यापेक्षा त्याचं स्पीड इन्क्रीज होतंय. So at that situation the motor it will be start unbalancing or unstable operation. It will leads to unstable operation. So therefore these types of machine, that is differentially compounded motor, it cannot be used for a particular application. It is rarely used. Okay, not mostly used, it is rarely used, or it cannot be used for a particular application because of their unstable operation. Okay, getting? So this is related to application of DC compound motor, that is differentially compounded motor. Getting, all of you?
Yes, sir.
Okay. Is there any doubt in all these characteristics? Series motor, shunt motor and compound motor, तिन्ही मोटरच्या characteristics मध्ये कोणाला काय डाऊट आहे का?
No, sir.
No, sir. No, sir.
Okay, so in this way we will conclude this today's lecture. Our today's point, that is losses and efficiency, we will see in the next lecture. Okay, so in this way we will conclude and we will stop here. Thank you.